Okay, recording has started. So welcome to today's session on design patterns, right? So I made slides for you guys because I felt like just writing it down is just, yeah, I don't want to be typing. But there's a lot of information in design. Design pattern is actually its own topic. It has its own textbook. So there's quite a lot to cover there. And I think I didn't even cover like most of it. I just covered the basics. So we're just going to look at an introduction. Today's session is mainly focused on understanding the design patterns themselves. Like what's the whole purpose? Why do we need them? Admit this person. We're gonna try to understand why design patterns are important. So today's class is roughly gonna be it's gonna be short, maybe 30 minutes to an hour there. So let me see. Okay, I need to press here. Okay. So why design patterns, right? Why do we need design patterns? So design patterns, its main purpose, right? It's for reusability. So basically we need, it's a way for us to create a solution to a problem in such a way that we can reuse that same solution in the future, right? It's basically its main purpose is like, when you're managing stuff and when you want in the future, when you want to add new features to your app. Let's look at it in terms of in this perspective of apps, right? When you're making applications, let's say your users, they've been sending out reviews and saying, we don't like Instagram because of this and that. Can you add this? So you see, we are adding. So that's that. If you're adding something, obviously there's gonna be some similar like common things. Like basically, there's gonna be some similarities in the way you're adding stuff. So you can find a way to model that in such a way that you can reuse it and not have to repeat yourself all the time. Another example of reusability, right? It's like instead of we try to help you. Okay, reusability. I'm actually explaining other points there. So reusability in simple terms, it's creating a solution in such a way that we can reuse it as many times as we can, right? That's design patterns. And design pattern is called design pattern, right? Because it's a way to we are doing design here. Basically, it's like we are being architects, right? We are being architects of software, right? We are not modeling the real world or houses or anything like that. We are modeling software. And so when you model software, especially design patterns, they use classes and objects, right? So basically, we are doing OOP. We are designing, we are coming up with a design for our software using OOP, right? This involves things like inheritance, base class, subclass, all those things, but then modeling it in such a way that in another way to view design patterns is that when we add something new, basically, for example, we want to add a new class, it shouldn't change much in our app, right? Basically, I don't have to delete and create a new class, delete that class. I don't have to do all of that. It helps prevent all those things. I can simply just edit without affecting all the other parts of the app. Design patterns are very useful in that scenario. So as you can see, reusability, number one main thing. And then design patterns, as I've stated, they are necessary for the maintenance of object-oriented software. So that when we want to add features or remove them, it's what's that word? It's seamless, right? It's a seamless thing, meaning it's a smooth process. I don't have to change much in my UML, in my classes. I don't have to delete a lot. Basically, we should actually avoid to delete and focus more on adding, but then you can delete sometimes. So that's what the textbook says. It says that you can either add or remove them. So you can either add or remove those features, right? And it should help with design patterns. It helps us make that process of adding and removing easy in such a way that we don't get errors, right? When we add those features or remove those features. And then design patterns can also help prevent this issue of rediscovering something. So for example, when you're finding a maximum of a number or maximum in an array, it's the same formula. So why don't you just create, if you remember things like the classes the code you wrote for semester test 2, right? You're using things like buffered input stream, buffered output stream, data input stream, scanner, print writer, all those things. We're actually using design patterns in a way because you're avoiding this thing of having to rediscover stuff. And that's why we also use the collections class to sort. If you remember, we did sorting. You could have rediscovered yourself, meaning you could have did something that we call trial and error, but then that's going to take a lot of time. And there's a high probability of you making errors because you're not you don't have a PhD in computer science. You are not that knowledgeable. You don't have extensive knowledge and experience in computer science. That's why we need things like design patterns. Majority of these design patterns, they're actually implemented in the classes that you import in your project, in your Java project. Majority of them, they're used there. So they're actually, in a way, kind of giving you a glimpse of how they implement the things inside Java. They use the design patterns. They're very important because, for example, software, right? Remember, Java is technically software. It's like an app, but it's an app that helps you build other apps. It's technically, yeah. In a simpler way, you can put it like that. It's like an app that helps you build other apps using the language Java. So that app, obviously, some people who are Java enthusiasts, basically people who code in Java, they might say, send an email or contact the board of directors who are managing Java, who own Java, and tell them, as developers, as software engineers in the industry, we've noticed that every time we use Java and we use this class, we get this and that, blah, 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 blah. Why don't you guys add this feature? Or why don't you guys remove it? It might sound like a simple operation, but to be honest, if you don't model and design your classes perfectly, to delete that class, it might affect everything, the whole thing. That means they might actually take a whole year to remove one feature. That's how companies in the industry are able to keep up with the demands of clients. They use design patterns so that when they want to add something or remove something, it's a simple operation. They don't have to affect the whole system. It only affects a smaller part of the system, and then they make those changes, and then maybe they tell you that within a week the features added. Just like that. It's not magic, it's proper designing. Because as software engineers, right, for those doing informatics, next year you're gonna have a group project that you do the whole year, which you're gonna present to people from the industry. We have over around 5 years and above of experience, some even 20 years of experience. So you need to know your stuff. So you need to use design patterns. They're gonna ask you those questions, and that's basically what's done in the industry. They use design patterns to model whether they're making a website like Ulink, like right? Ulink, like Eve, all of those things, they use design patterns, all of them. It's actually practically impossible to not use them. That's how fundamental design patterns are. They are annoying. I do agree. There's quite a lot of them. There's like around 23 plus, right? But then you guys are not going to do all of them. You only focus on the ones that are on the slides. So even if you are reading the textbook, only focus on the ones that are stated on the slides. And then, as I was saying, emphasis on the design and patterns, right? Meaning that these design patterns, they help us model or design recurring patterns or solutions to problems. So basically, we find a way to model problems that keep on recurring, right? And those problems, they all have the same solution. So why not just save it? Just save that solution and then just simply reuse it every time you encounter that same problem. That's basically what design patterns are trying to achieve. And then we're going to go to the next slide. Yeah, so now we need to understand what is a design pattern. We understand like why is it important for reusability and things like that. But what really is a design pattern? If you check in the textbook, they put a small quote, Yana, there to say that there's someone called Christopher Alexander, right? You can go research on him. He says that each pattern describes a problem which occurs over and over. Remember what he said? He said it's a recurring problem. I shouldn't have said solution. I should say problems. Yeah, so basically we look for a problem that keeps on repeating itself. That's basically what design patterns do. If they look for a problem that most engineers always encounter or always have to face, that problem that they face, since it's a common problem that keeps on happening over and over, you choose a pattern, a design pattern, or a solution, because design patterns are solutions. You use that solution to solve that problem. So he says that this is each pattern describes a problem which occurs over and over again in our environment, and then describes the core of the solution of to that problem in such a way that you can use the solution a million times without ever doing it the same way twice. Meaning, as I was explaining, you don't have to repeat yourself, because if you were to rediscover everything, meaning every time you make an application, you redo everything. That means every time you make a new application, you actually have to you have to actually create the programming language from scratch, then use it. Imagine you do that every time you build an app. That's gonna take time. That's why when you download a programming language, it comes with things. For example, C++, we have header files, right? Which uses those design patterns and those classes, or it's those things that are problems that commonly okay, right? But design patterns is not the full solution. It works as a template. Basically, it's like a general way of solving the problem. It doesn't mean that it's specific to a specific problem, right? It's a specific solution to a specific problem. No, it doesn't mean that. It's like something that you use as a template. Then you make some modifications so that it applies to your problem or um to your um to your practical, right? It serves as a template. It doesn't mean that's it's actually the actual solution. No, it's a template. And then this design, like I said, design patterns, they use classes and objects. Basically UML. You'll notice that on the slides, there's a lot of UML, right? Because it uses OOP to solve problems. And it kind of makes sense to use it in Java because Java is mainly OOP, right? From the ground, it was built to accommodate OOP, meaning that everything in Java is viewed as an object. And design patterns, they excel in that language because Java views everything as objects and classes. So you design using objects and interfaces and classes. And then, like we said, a design pattern is a solution to recurring problems. Basically, those problems that keep on coming, they keep on they occur over and over, right? Design pattern solves those problems by giving you a template, not the actual solution, but a template that basically it's like you can start from here. This is like this general, right? That's basically what design patterns are, just general, meaning you start from here, then you change it to be applicable to your problem or to the problem that you're trying to solve. Okay. And then the patterns, design patterns, right? They have these four things. All design patterns have this thing. They have number one, what we call a pattern name. Basically, it's like what it goes by, its name. In the textbook, they call it a handle that is used to describe the pattern. For example, like an Instagram handle, right? A handle, that Instagram handle, again, it's used to refer to that specific user. In this case, this handle is used to refer to that specific design pattern. So yeah, in the textbook, they use the word handle. And then it is the problem, which is basically the problem basically describes what the pattern solves, right? And this problem that you can say that it's the problem that it solves or it tries to solve. And this may include that problem can include conditions that need to be met in order to apply it. Remember design patterns, right? When you try to apply a design pattern, it's a very, very, very important to look at the conditions. Because I don't know why, but then most design patterns, they're very similar. Like they can be like some design patterns, you can be confused, like which one is which. That's why you need to actually understand that which conditions need to be met in order for this specific design pattern to be applied. Because when you know the conditions that are needed, that need to be met, then you can know which problem needs to be solved. If you know which problem needs to be solved, each design pattern describes which problems it solves. So now you'll be able to find the right design pattern for that problem because you've understood the requirements that need to be met or the conditions that need to be met. Then we have the solution. So that design pattern, it also has a solution that basically it proposes a design that solves the problem. Remember, we use UML to solve this thing. At the end, even though it might be UML, at the end of the day, we're still going to implement it in Java, but it starts as a UML design. So solution, this is the design proposed in order to solve the problem stated, which is what each design pattern has. It has a pattern name, the problem that it tries to solve, the solution that it provides, right? Or it proposes in order to solve a problem like that. And then it has things like, there's also things like consequences that you need to understand. It's basically the costs and benefits of applying the pattern. So in terms of costs and benefits, right? In the textbook, they talk about things like space. Because sometimes some UML diagrams, they can actually consume a lot of space. By space, we mean your storage on your computer. So that could be a cost. Some design patterns are they're heavyweight, right? By heavyweight meaning when you use that design pattern, you use more space. Then there's other design patterns that are kind of lightweight. That's why it's very important to understand the problem you're trying to solve. That's the main important part, understanding the problem. If you understand the problem, for example, they say in the problem, they say they want a lightweight, blah, blah, blah. Obvious, that means that any design pattern that has what's that English word? There's that word. Yeah, any design pattern that's very expensive to use, expensive in terms of memory. All those design patterns that are expensive in terms of memory, you don't use them. Because in that question, they say the problem that they want to solve, they want something that's going to be lightweight. That's if they told you, right? So it's very important to understand the cost and benefits of that design pattern. To be honest, I don't know how you master this because I also didn't master it. I don't think anyone has mastered it. You just need to read it and understand which way to apply. And then once you're in the industry, just simply open the textbook. Then as long as you understand the basics, then you can know, oh, maybe I need to use proxy here. Or maybe I need to use factory design pattern here. Or maybe I need to use the visitor here. Without knowing how it's implemented, you can know the basics because you're a human being after all. You can't possibly know everything. And then some examples of design patterns, right? Remember, we said design patterns uses UML, basically classes and objects. An example of design pattern, you can look at it in terms of like acting, right? Like actors. You obviously you need to identify the actors that are involved in that movie, which is basically your classes and instances. And then each actor has their specific role. For example, in collaborations, right? Each actor has a role that they need to play, and they need to be able to collaborate, basically work together, even though they have different roles. For example, one person in the movie can be it can be a bartender. One person can be but it can pretend to be that the main actor's neighbor. So you're defining the roles and collaborations. So it's design patterns that also have that similar approach, whereby you identify the actors, which is your classes, your interfaces, your objects. You identify all of them based on the problem. Then you identify their role. Which role do they play? And their collaborations. Basically, how do they interact with each other? Remember, if you are in a movie and you are speaking to another actor, it's two, you can actually technically view it as two objects communicating with each other. It's the right terminology for it is two living objects because you're alive, right? You breathe, unless maybe you're a zombie. But yeah, it's two living objects, but they're still objects that are interacting or collaborating with each other. is the same thing with design patterns. You're going to create design classes that collaborate, whether it's through inheritance or it's through what's that word? Through realization, meaning you are realizing an interface. It's still collaboration. It's basically sort of like a relationship between the objects, right, or the classes. And then there's also a distribution of the roles. Basically, it's kind of similar or exactly the same thing as their roles and collaborations. Kind of it's the same thing because you just simply distribute the role. That okay, this is gonna take in the role of this. This actor is gonna act as the main actor or the protagonist, and then this one's gonna be the antagonist. This will be the what? This will be, everyone has their role. This will be the cameraman. This will be the script writer, all those things. There's a distribution of roles, and then each of those instances or classes, they now collaborate and interact with each other. So we're trying to model something similar to that. And then here I just added an example of of any movie or anything or actors. So all of these actors, right? They have their own role. He plays as the main character, and then he plays as his wife, right? Somewhere along the line, they plays as his wife, and then they have a kid. That's their role, right? But then at the end of the day, you can view each actor as like a class or an object. So this can be an object or a class. This is an object or a class. Maybe this is an interface. It interacts with this one. Basically, that's why I was using the acting example, so that you kind of picture it that it's an actual interaction of objects. They communicate with each other, right? So that's that. And then we have there's not much to explain here when it comes to like talking about the design patterns themselves, like the motivation behind design patterns. The thing that's gonna be too involved is the actual implementation of each design pattern, like the visitor, proxy, factory, abstract factory also is there. Yeah, I don't know if we can cover all of them though. I think we can't, like, because I'll see how I'll choose the design patterns. But visitor is a design pattern that's most common in ComSci 2A. That one is very common, visit. And then maybe factory, I think factory, maybe factory. I forgot the other one, so I'll have to double check. So each design, there's a criteria, right, for design patterns, right? There's two, it is purpose and scope, right? And then purpose, each design pattern, purpose you can view it as like the category, right? Each design pattern, it falls under a specific category, or it has a specific purpose. Basically, what it's intended to do. Basically, you can view it as like at its core, what does it actually do? Or what type of problem at its core that it's trying to solve. In this case, we have creational, structural, and behavioral, right? Creational is related to object creation. If you have an application whereby you are creating some instances, right? You're creating, let's just say it's an application whereby you're creating things quite a lot. Like you're creating objects quite a lot. You keep on creating. Obviously, you're going to need a design pattern to achieve. Remember, we talked about it at the beginning, to achieve reusability, because we need to reuse. One thing that programmers don't want to do is repeat themselves. So if you see that we have a problem that is a lot of creation, it's a creational problem, right? Basically, we creating objects. We need to find similar things or similar parts that we can extract, right? And then design it as a template in a way, because the design pattern is a template. Make a template for that and say, this is the template. So every time you want to create an object, you use this template. Even though that template it serves as a template, you can modify it to be applicable for that specific problem. So that even if you have another different problem that requires creating instances, that same design pattern can still work in that scenario. Because remember, design patterns are simply templates. They don't solve it. Basically, you don't create a design pattern for Instagram. That's too specific. That's not how design patterns are. Design patterns, they just say, this is the template, in general, this is how you do it. Then you as a developer, that's your role to take that template and apply it to your problem. Or apply it to your problem and make it as part of the solution to that problem. Because design patterns is a way to provide solutions to recurring problems, right? By recurring, it just means it comes over and over, right? Those problems that come over and over. We keep getting those same problems, then obviously if there's a pattern right there. So we don't, yeah, there's that, yeah, that now I feel like now you can kind of get it. Design pattern. If it's recurring, right, that means we're gonna see a pattern, of which that pattern we can create a design for it. So therefore design patterns, right? So it's a way for us to design a template for recurring patterns, basically patterns that usually occur when you're solving problems in this problem domain. We have the creational problem domain. Basically, when you're trying to create objects, anything that has to do with creation. If in your code, in the question paper, they say, hey, you have to create this and that, and then create the moment it says create, you know that you now narrow down the list of design patterns you need to choose from, because they said create, we are creating here. So you only focus on the design patterns that are mainly focused on creation, right? And then then we have another one, which is structural. Structural is basically mainly focused on the structure itself, right? For example, how do I put it? For example, is it a building or a house? Right, that's the structure. Is it 2 floors or 3 floors? Does it have an elevator inside? You see, that's a structure, right? It's like how it's how we structure the classes and interfaces, and also objects, because objects also form part of um, design patterns. So it's related to how you want to structure the classes and interfaces, right? Then we have behavioral, basically how they behave. As it says, behavioral. It's how these objects and classes behave when they interact with one another. If in the question paper it says that so and so needs to send or delegate this task to the so and so, you see, that's behavioral. Yeah, there's interaction there. You're interacting. You're telling you're communicating basically. Basically, the behavioral, you can view it as like here, right? Remember this image. When the actors act, what do? They communicate with each other, right? Or the right term for it is they interact with each other, right? It's the same thing. So if you have a problem that requires interaction, like communication, things like that, you definitely know that, oh, this is the behavioral. That means I need to remember all the design patterns that are behavioral design patterns, meaning design patterns that are related to how the objects and the classes communicate or interact with one another. Then you focus on there. Then you look at each design pattern and you try to find out what is the most correct design pattern. Because even if technically you could choose any from that pool, right, from that category, but it doesn't mean that's the right one for that problem. You'd actually need to do a further investigation, which means, to be honest, you actually need to know every design pattern, which is diabolical. But yeah, that's what they expect you as second years. You need to know every design pattern, because they can ask you anything. Is it creational, behavioral? And they can also sometimes they can ask you to compare. Maybe they give you one behavioral and one creational. Then they say compare them. I don't think they'll take it as far as compare using diagrams. Now that would be too complicated. But maybe after that question, you can have another follow-up question which says, choose the right design pattern for this problem and model it. They need to see the UML. So that means you actually need to know everything, because they can bring it randomly. Maybe they say this just bring procs. And when you're creaming Abu factory and visit, then they bring procs. Maybe you might get, you're not gonna lose marks, because like I said, these design patterns are similar. They're related. Some design patterns are so similar that you can, when you look at it, it's like it's one or two classes that are different or function that are different. But it's similar. That's how similar they are. That's why it's a very tricky with design patterns. You need to really, really study and understand it. Not necessarily with the diagrams part, right? You can narrow it down and look at past papers and focus on the ones that they tend to ask more if you want to cram the diagram. But then in terms of understanding the design pattern, you need to read each and every single design pattern and understand its purpose, why was it created, what problem does it solve, all those things, its cost and benefits. If you use this one, what do you benefit? What do you benefit from? Maybe some design patterns, because I haven't read the design patterns, I just only read the introduction. Maybe that design pattern, it makes your code faster, something like that. It's for speed intensive application, something like that. So that would be a benefit. But and then if it makes you use more memory, that means that's a cost. So you'd have to check which one. Oh, this one is the cost of memory. This one is what speed. This one is this. This one is that. This one you need to. There's quite a lot of studying there, and slides are not going to help you. I don't want to lie to you. Design pattern slides are not going to help. And then we have how to select a design pattern. This is just how they stated it. They stated it in the textbook, right? I was reading that one, the one written by Gang of Four, right? GO4. The actual people came up with the design patterns. I guess they released the textbook or a book. So I was looking at they gave this as like sort of like a guideline on how to know which design pattern to choose. So they say you should consider how the design pattern solves design problems. So basically understand how that specific design pattern, right, solves a problem. Because in the question that they gave you, right, there's a specific way they want you to solve that problem, right? So you need to understand how each design pattern solves the problem. Excuse me. You need to find out each design pattern and how it solves that specific problem. Once you understand each, then you can kind of link them and be like, oh, this one solves this one solves that. But then this question wants this. So it means, oh, it's the facade. I don't know how you'd get to that level, but it takes a lot of reading because design patterns are not easy. And then you need to scan intent sections, right? So basically you need to understand the pattern's intention. What does each pattern intend to do or intend to solve? Something like that. The intention of each pattern is very important because like I said, the patterns can be similar, but then they can vary or they can it can be they can have differences in terms of what their intention is, right? Even though they are similar in the way they are designed, but then some they have different intentions, right? And then we have study how the patterns interrelate. We talked about that. How are they related? So you need to make sure that, oh, this one, we have the factory and then we have the abstract factory. How are those two related? Because I see factory. That's what they mean. You need to understand the interrelation, right? How are they related to one another? So that you don't confuse them. The main goal here is so that you don't confuse yourself. That's the main goal here. And then study patterns of like papers, basically look at similarities between each patterns. These people, that's why I don't like the people who are too intellectual. They they write the same thing, but then they phrase it in a different way. Interrelation is similar to what they're talking about here. Basically, they're saying look at their purpose. Basically, what's their purpose? What's the purpose of that design pattern? And remember, we talked about design pattern. It's either creational. Wait, my bad. I skipped scope. We'll go back to that once you're done. I skipped scope. So you need to look at this purpose. Basically, is it creational, structural? To be honest, you can kind of narrow it down. Like I said, you need to look at what you're trying to do. Does the question say you need to create objects or creation some way, creating something? That means you only look at design patterns under creational. Structural, they said it should look like this, it should be like this, it should be structured in this way. I doubt they'll use the word structure. They'll try to trick you and use a different word. But if they did it that way, then I'm only looking at design patterns under structural. So that's what they mean. You need to understand its purpose. Examine the cause of redesign, right? What might force a change to redesign? So basically, you need to look at each pattern or each design pattern and look at what might cause it to be redesigned. They do explain in the textbook each design pattern, what might cause it, what might result in forcing the user to redesign the design pattern. Then they're telling you that so that you avoid making those mistakes, so that you are not forced to redesign the whole thing. So that's what they tell you there. They want you to go look at the cause of redesign of each design pattern so that you avoid it in the future and don't have to redesign. Because if you have to redesign, that means you start the whole application from scratch. Imagine trying to build Ulink from scratch. That means some students have. That means UJ has to stand still maybe for at least 6 months or so while they try to build it from scratch. Do you see the problem with that? And that time they're building it from scratch, right? They have to redesign, and it's simply because they couldn't. I don't know. Maybe let's say they they had set a limit that the maximum is always 55,000 students. And then all of a sudden they introduce a new campus. So that means the maximum has increased. That means it changes everything, the whole system. If they're not using design patterns, there's going to be a cause of redesign, meaning you have to redesign the whole system. That means basically delete everything. There won't be any Ulink anymore. Then they start from scratch. Do you know how much time that would take? So that's why you need to understand the cause of redesign, what causes each pattern to be redesigned, and avoid it. Because there's definitely something that will cause each design pattern to be redesigned. So they want you to look at what might force a change to that design pattern and avoid that. So that in the future, you're not forced to redesign the design pattern. Then we have the last one, consider what should be variable in your design. Basically, what should change? What here it says what you are able to change without redesign. Yeah. So basically, if the other one focuses on trying to avoid redesign, the other one focuses on what needs to be changed. Right? What are you able to change what are you able to change without having to redesign the whole thing? So that's basically one of the things you can use to select a design pattern. I doubt your slides explain. I don't know, but I remember those slides. They barely explain the slides. And the thing is, the textbooks for design patterns, I was searching. I can't find it. It's like it's not serious, but it's a serious thing. Like they don't. I don't know. There's not a lot of textbooks, and the textbooks that are there, they're specific to a programming language, which is a problem. Because if they're talking about JavaScript, you guys are not doing websites, so it's totally off topic. So that's the problem. Yeah, I skipped scope because remember we said that there's a criteria for design pattern, which is two, purpose and scope. You need to know in which category does it fall in. Once you understand, then you look at the scope. Basically, we have three, right? You need to check whether the pattern applies to mainly or primarily object classes. So basically, you need to, because design patterns, right? Every single design pattern, it kind of comes in two forms, whether it's under creational, structural, or behavioral. It always comes in two forms. It's mainly focused on classes, meaning there's things like inheritance and things like that. Basically, it's focused on classes and subclasses of those classes, or it's focused on objects that are interacting with other objects. They're mainly like that. It's mainly focused on objects or mainly focused on classes themselves. So you need to understand, you need to look at the scope. But when you look at the problem, you need to look at it, oh, this problem, does it actually refer to classes? Oh, then I need to look at design patterns that are mainly related to classes, right? Modeling of classes, which would be things like interfaces, UML, all those, not UML, interfaces, inheritance, right? Mainly inheritance. Inheritance is used quite a lot in design patterns. Like that's the thing that's used the most, especially if you're dealing with the scope is based on classes. Inheritance is there some way. And then number two, class pattern it deals with relationships between classes. Yeah, that's what I was explaining. It's either it's design patterns that are dealing with classes, mainly classes. So that means you need to look at things like inheritance, interfaces, all those things. So when you have class patterns, the class patterns mainly deal with relationships between classes and their subclasses. And since it mainly deals with subclasses, with classes and subclasses, it's static, right? Meaning it's fixed at compile time. Meaning Java is gonna handle everything by the moment it's finished compiling at compile time when it's finished compiling. But then remember objects. If you remember how objects work, you can actually, for example, an array in Java, I guess it's an object. So it's a reference type. So what if you get the size from the user? So you see, it's actually based on the runtime. Basically, when the application is finished compiling and now it's actually running. So object patterns, right? Patterns that are related to objects. They deal with relationships between objects. And these tend to be dynamic, meaning they're flexible, right? It's not like static. Static, like it's like in a way, it's like it's fixed, right? It's like not gonna change, right? And because it's not gonna change because it's picked up at compile time. Remember, at compile time, whatever you've written at compile time, it compiles it into the Java bytecode and then machine code and things like that, and then it's done. But then with objects, it goes a step further because we also get input from the user, so it's dynamic in that way, meaning they're fixed at runtime, right? Because we're dealing with objects. When we're dealing with classes, just know it's compile time. If you have design pattern that's related to an object, then you know it's runtime, basically when the program is running. And then we have this last one, which is the last slide. Then now, how do you use the design pattern? You just simply have to follow this because I'm just simply naming most of the things that were written in the textbook, right? Especially this part, you see here and here, right? It's things that were mainly listed in the textbook. The other parts I had to kind of summarize it in my own way to make it short and things like that. So you need to read the pattern once through an overview. So basically, you need to look at basically you need to skim through the design pattern, right? You skim through it so that you understand in a nutshell what does this pattern do. And then once you understand that what it does, you can also I'm not sure. Okay, in the way they've structured in the textbook, it was numbered. I'm assuming it's in that order. That's why I also wrote it like this. I'm assuming it's in that order. Then once you've read the pattern, you go back and you study the structure. Basically, how is it structured? How is it modeled? All those things. What are the participants? Basically, what are the classes that are interacting with each other? We can say those are the participants. And then collaborations, things like interactions, right? It's just collaboration. And then you look at sample code to see a concrete example of the pattern in code, because sometimes when you see it implemented, right, you're seeing it, you're basically seeing how it needs to be used in the right way when you see it in code. Because remember here we're talking about how to use the design pattern. You need to look at the code example so that you know, oh, so if I have this, and then I need to have a visit function which visits this, and then I have a visitor, which is the person who's visiting. So, you kind of look at it in that sense, you can kind of understand it a bit better when you look at the code. So they're telling you to also look at sample code. Choose names for pattern participants that are meaningful in the application context. What do they mean by participants, right? The pattern participants. They basically remember what what you talked about. Design pattern is a template. So when you look at that template, you don't when you look at the slides, they gave you a example. That means you need to replace those classes with your own classes. That's what they're telling you there. And you need to use meaningful names, right? Use meaningful names. Basically, if you're given a paragraph, don't just be choosing random spiritual names. No, choose meaningful names that make sense. And then use the template of that design pattern replace those parameters with the actual classes in your problem. Basically, that anyway, they're trying to tell you to make the template or the design pattern apply to your problem. If you want to make it apply to your problem, if on the slides it was talking about bananas and fruits, and your question talks about students and lecture, you can't copy and paste the design pattern about bananas and fruits. So that's basically what they're saying there. You need to choose meaningful names for your solution for that problem. And I don't want to go into those details. Let me not explain what I was about to explain. Then you need to define the classes, basically create those classes. Because you can't pass, remember, a class is a way to define a new type, right? So you can create a UML whereby you're saying, for example, you create a function called visit using the visitor design pattern. In the function, there's a function visit that it takes in the thing that is supposed to visit, which is an instance of a class, right? You can't say take that instance when the class doesn't exist. You need to create the class itself first, then pass an instance of that class type. That's what they're telling you here. You need to create the classes themselves. Then define the application-specific names for operations in the pattern. So basically, define operations, right? It's functions, your methods. They're saying use names that you basically look at the paragraph you're given, choose the names that talk about that paragraph, that problem. Don't just copy and paste the template from the textbook. Make it apply. This thing, you see, if you notice something, right, it keeps on pointing back to you applying the design pattern to that specific problem. That's the main goal here. That's basically what they're trying to tell you. Even your functions, you need to rename them, use the names. For example, the thing is, I can't think of a design pattern right now, but there's some design pattern like factory, where you specify the thing that's going to be built inside the factory and things like that. So obviously that thing is going to be different and it's going to have different functions. So you need to rename those functions and not just copy and paste what you see in the textbook, that diagram. No. To be honest, it actually takes a lot of effort to master design patterns because you must understand the design pattern, its purpose, its scope, its intent, what was intended to do, all those things, its solution, what solution does it provide? Meaning you need to look at the code and the UML which represents the solution. Then cram it, know it in your head. Then once you're done, you apply it to the problem. It doesn't mean you simply copy and paste. No, you change the places you need to change, and you need to know where to change. That's basically what it's explaining here, how to use the design pattern. They're telling you don't just simply copy and paste it, or else you lose marks. You might get marks for things like the right design pattern. There's marks for that. I think it's like 2 marks to choose the right design. And then motivation, it's like what led you to that conclusion. Motivation is, I think it's usually 4 marks, something like that. And then maybe the last question they can be like, yeah, draw it. Just provide the solution, draw the diagrams. Design patterns are not nice. That's why I said semester test 3 is not nice. And then the last thing, implement operations to carry out the responsibilities. Since you've created the functions, implement them. That's basically what they're saying. I don't know why they like to use fancy English. They just say implement the functions. Simple, straight to the point. So that's basically all about design patterns in terms of understanding what their purpose and things like that. It's a way to model or create templates for problems that keep on appearing. So if you keep on facing when you get into in software engineering, right, there's problems that are going to keep recurring. Excuse me. There's problems that are going to keep recurring, problems you're going to keep facing. So instead of having to reinvent and become Einstein, imagine every time you write a break, you have to become Einstein. You have to discover, come up with the formula, prove it that it exists. That's a lot of work. You never get anywhere in life with that technique. That's why we always, even in C++, we had header files. You say hash include IO stream. You didn't have to worry about how C in and C out works. You just know like how it's implemented. That was none of your business. All you have to know is that, oh, I use it this way, how to use it, so that you can so that you can promote reusability. And if you notice something, we're coding faster, right? With practicals and everything, because we didn't have to reinvent the wheel. There's a topic in programming called make sure you reuse what other developers have used that have stood the test of time, right? Because all these design patterns that are put there, they've actually applied them in the industry, and then they've removed the ones that didn't work, and then they narrowed it down to around 20 something. So they've been tested by people with PhDs and professors with experience, 20 years and above, 30 years experience, people with proper experience. So it's better to trust them when they tell you that this is the template you can use, instead of having to rediscover something while coding. It will take you years. Yeah, and it's very important, the design pattern, because in the industry you maintain software. Basically, you add and remove features. So to add and remove, it can actually destroy the whole system. Imagine you are actually sitting in your bed and TikTok, they wanted to add a feature. If they didn't use design patterns, it would disturb everything. That means they'll tell you, no, TikTok is not going to be active for the next 5 hours because we are installing an update. If you notice, TikTok still works. All those apps still work, right? And then while they're working, you literally go to Play Store and you download the update while they're still running it. How do you think they do that? It's design patterns, so that when you add a feature and you remove a feature, you don't affect the whole system. You only affect only a small case, a very small part. Sometimes it might not even affect anything because you're just simply adding a new thing. If you look at the diagrams on the slides, the design patterns, everything, you'll notice that if you try to add a new instance, right? Remember we talked about that there's design patterns that are focused on mainly on classes, right? Then there's ones that are focused mainly on objects. Let's talk about the ones that are focused on classes. If it's focused on classes, right, that means we can, let's say we have, okay, what do I mean? Let me make an example. Let's say you have an abstract base class called fruit, and then you have subclasses, mango and banana. What if in the future you discover that, oh, there's apples? Obviously, you want to add apples without affecting mango and banana and fruit. Basically, you don't make changes inside the banana and mango and fruit. You don't touch them at all. You simply create the new class and start coding and make it extend. That's what actually, to be honest, in inheritance it kind of uses design patterns if you think about it. Because if I want to add a new class, what do? I simply extend the base class. I don't. It doesn't affect anything. So if I'm making these updates or adding these features, people who are running the version with banana and mango, their app won't stop running because the class that I'm adding, it doesn't affect them. That's the main goal. That's the main goal of design patterns. If you understand that part, you should be good. Because now you can look at the code and be like, oh, I see. That means if I add this thing, it doesn't affect all the other thing or all the other classes. So, oh, this design pattern is actually useful. You can start to see that. So yeah, I hope I made some sense. This thing doesn't make any sense. If you if you don't really sit down and think about it, it doesn't make any sense. You need to read and read and read. Then one day you get a light bulb moment. You're like, oh, I get it now. But I hope it makes sense. Yeah, that's it for today's session. And then tomorrow we'll let me see. I think we'll start with visit a design pattern because like visitor is always there. We'll start with visit a design pattern. So we'll start tomorrow. Start with visit a design pattern. I have to make slides on that. Hey, it's quite annoying. But it's fine. I'll have to make slides on visitor design pattern, and then we implement it inside the Eclipse, And then we try to make changes by adding adding a new feature, like adding a new thing. Then we see if it's going to affect all the other things. So that we can see practically and see, oh, there, I see now there's that design pattern. Oh, so if I add this, it didn't affect my base class, it didn't affect my interface, didn't affect this. I just simply added it. So I think it's also good to see it in that way. Like I said, I think we might not manage to cover all of them, but it's quite a lot. I think you guys are doing only focus on 11 or 10 design patterns out of the 23. You're focusing on 11 or 10, and you must know all of them, even their diagrams. So you guys better go study. So let me stop recording. Yeah, we'll focus on tomorrow's session. I doubt you have any questions because we haven't done the actual